Using the set operators. In this nugget, we continue our work with the SQL select statement. By way of review, we started by using select to grab rows from a single table and then gradually worked our way broader and deeper with select and learned how to use joins to extract rows from multiple related tables. Finally, by now, at least if you've been watching the Nugget movies sequentially, you also understand how to embed select statements in other select statements. This is called the subquery. In this particular nugget, we're examining first SQL as a set-oriented language, which is what it is. We're going to define what the word set means, so don't worry about that. We'll then learn how to combine the results of multiple select statements by employing what are called set operators. There are 4 of these that we need to know for our exam success: union, union all, which is really just a variant of union, minus, and intersect. Let's get to work. By way of preliminary terminology, let's define what a set is. In mathematics, a set is referred to as a collection of distinct objects that are considered an object, or is considered, I should say, an object in its own right. And as I said in the previous whiteboard, SQL, or structured query language, is considered a set-based language. Now, when you deal with sets, both in terms of pure mathematics as well as SQL, we often find it helpful to visualize the behavior of those multiple data sets by using what are called Venn diagrams. You should already be familiar with what Venn diagrams are because we used these in the previous nugget dealing with joins. Now, in structured query language, a set is going to refer to one or more rows. That should make sense. In our work with the select statement thus far, whether it's a select star that retrieves all rows and all columns, or if it's a more refined select statement that has a discrete select list and then further filtering, for instance, with where and ordering with order by, the results of that operation will be, sure enough, one or more rows of data that can be worked with as a discrete or distinct object, considered an object in its own right. In other words, it's a set. So as I already mentioned, the set operators that we're going to learn how to use in this nugget enable us to combine results from 2 or more select statements. Now, you can in fact involve, as this says, more than one select, more than 2 selects. You can keep going depending upon how many tables of data, or should I say how many discrete selects, you want to aggregate. Now, why are set operators useful? 2 main reasons are 1, data warehousing, and 2, comparing tables. A data warehouse, defined by Wikipedia, is a database used for reporting. So the idea with a data warehouse is that it's not necessarily an online transaction processing database that you'd use in production that's experiencing frequent writes, deletes, updates, and other changes, but the data warehouse tends to be used for analysis purposes, what's called OLAP, online analytical processing. And in that case, especially where you have tables that aren't fully normalized, and remember, we talked about what normalization is earlier in this training, you may find that aggregating tables selects from multiple tables by using statements like union and union all can really help your business analysts make better sense of your data that's in that data warehouse. Comparing tables, we're going to finish this nugget before the demo by my showing you some fancy footwork combining 2 of these set operators to compare the contents of one table with the contents of another. You may, for instance, want to be double Dutch sure that every row in one table matches every row in another. What would this be useful for? Well, maybe if you want to make sure that your staging or development environment matches exactly the current state of a table in your production environment, or vice versa. Now, we have some guidelines to consider. We could also call these gotchas for doing set operations in SQL. First of all, for some but not all of our set operations, the order of the selects is particularly important. Now, we're going to see that that really comes into the forefront with the minus set operation, where you're taking one set and then you're subtracting another set from it. So here, of course, you want to be really careful that your first select is in fact the set that will be subtracted from. You see what I mean? Another set operator guideline deals with column aliasing. We know how to alias columns in our select statement, and we know why aliasing is helpful. It makes your selects easier to understand, especially when you're joining data from multiple tables. Well, as it happens, the results of a set operation, let's say you're doing one select that retrieves 3 columns worth of data from one table, and then you're going to union or combine that with a select with the same 3 columns from another table. Well, in order to make that resulting set plus set equals set, if that makes sense, make that more legible, you may want to alias one or more of those column names. As you'll see in the upcoming demo, you want to do your aliasing in the first select statement. Oracle will take those hints as it processes the set operators by processing column names from your first select statement. So keep that in mind if you would. Another point that hopefully is crossing your mind right now is, well, if we're taking some columns from table A and unioning them, for instance, that looks like a face too, I don't mean that, with another select statement that takes, let's say, 2 columns worth of data from table B, well, what's that going to do as far as data types go? Maybe the column names don't match. Maybe the data types don't match. Well, you need to be careful when you're using these set operators that your column numbers and data types match as closely as possible. Column number is just a given. If you're selecting 2 columns from table A and unioning those with 2 columns in table B, those columns don't necessarily have to have the correct name or the same name, but they do have to have the same order. So if we wanted emp ID and emp department, and then emp ID and department name, let's say, from another table, you'll notice that the 2 department name columns have a different name. That's okay. But we want to make sure that we don't, in the second select statement, put our select list as department name, comma, emp ID. We want to keep those column names parallel. And while it's the best case to have the data type match exactly, remember what I taught you earlier in the course about type casting. That is to say, performing a data type transformation on the fly as the query is being compiled. And that can happen implicitly or explicitly. There's a built-in function in Oracle called cast. We have tochar and those various conversion functions that we looked at earlier in the training. Oracle will also implicitly attempt to match data types to process the query, but I think if you've learned anything about me as an instructor or as a database developer so far, you know that I don't like ambiguity very much in my SQL. Therefore, I really want you to think about those data types and have them match and do explicit typecasting where possible, just to reduce or eliminate any possibility that Oracle will get confused. Finally, if you're going to stack set operators, and what I mean by stack is using union, minus, or intersect in a chain in a fairly complex way, you can be more explicit in terms of which operations you want to happen before other operations by using our friend parentheses. Remember that in the order of operations, parentheses trumps all other comparison operators, and Boolean operators for that matter. Now then, let's get down to a discussion of the main set operators in Oracle SQL. The most common of those is called union. And no, I'm not referring to the progressive rock band Yes's album Union. Yes is one of my favorite musical groups. But I'm referring instead to the ANSI ISO standard in the SQL language that is fully supported, of course, in Oracle SQL. Formally defined, the union set operator returns all rows from multiple tables. Now there's no join condition here. You're literally just taking one select statement and another select statement and dumping all of those results into a single resultant set. Hence the need to be careful with your column ordering and your data type so you don't get any clashing. Represented as a Venn diagram, you see here we have 2 queries, overlapping circles, and we're taking all content from both circles. So technically, these circles should both be filled in to denote that we're just taking all data from both of those queries and then, as I said, packing it into a single result set. Now, what you need to understand is that union used by itself will remove duplicates. That is to say, as those queries are processed, If there are any duplicate values between those queries, those will not appear in your resultant set. That's just how union works by default in Oracle SQL. If you do need to include duplicates, you would use union all. And the Venn representation of union all looks like this: Q1 and Q2 as discrete circles, where you're returning everything from each query. There's no intersection of matches that are extracted, or duplicates, I should say, that are extracted. Final point, and this I probably should have put in the gotcha slide, but here is just as well, I reckon, and that is all of our set operators, none of them do any implicit ordering. Now, I'm preaching to the choir here. You should already know this, that if we need ordering in our result set, we need to use or include the order by clause. We can use order by with our set operators in exactly the same way that we can use them in other contexts. Whereas union is perhaps the most common set operation and is used, as we said, to take two or more select statements and put them all together into a pool, as it were, minus functions quite a bit differently. First of all, if you have experience with other relational database management platforms, for instance Microsoft SQL Server or MySQL, you will probably be thinking to yourself, what is this business with minus? Don't you mean except? This particular set operator is kind of quirky in as much as Oracle has named it differently. We use minus instead of except. So just keep that in the back of your mind as you take your exam. But both of these keywords do the same exact thing, and that is you're subtracting one set from another or finding a difference between those two queries. So the Venn representation shows query 1, and then we have query 2, which is subtracting itself from query 1. Now, this is useful not only when comparing results from two separate tables, but you can run a query from a single table, and then to eliminate part of it, you can run a minus operation with a second select, and that second select would effectively remove a subset of those records from the first select. So as you see here, the cross-hatching represents the second query, and then what you're left with, if I can use these geometrical shapes, is a shape that looks something like this. So again, minus is particularly cool for cleaning data, and you can run minus against the same table, two selects against the same table, or you can do them with multiple tables. It's completely up to you. But as I mentioned earlier, and this bears repeating, the gotcha is you have to know exactly which query is going to be subtracted from. The first one then receives the subtraction from the second query, okay? The third and final set operator we're looking at in this nugget is intersect. And like union, it doesn't matter which order your selects come in. Thus far, of the three set operators, the only one where the order of your selects is crucial is minus or except. With intersect, you're looking at common values between those sets. So represented in a Venn diagram, this is what you've got, and this light area is going to be what's retrieved as a result of the intersect. You're gathering just common values or common matching data. Now, of course, you're probably thinking to yourself, isn't that exactly what happens with an equijoin, or also called an inner join? And the answer is yes. So your next question would be, why would you use intersect versus an inner join? Well, intersect is going to place restrictions on columns pulled from both tables. The biggest or kernel difference between the intersect operation and an inner join is that intersect is operating on every column indicated in each one of those queries. So remember, we have our first select that, let's say, involves 3 columns, and then if we're doing an intersection with a second select, again, we have to have column numbers that match. We're matching on all of those columns. By contrast, when we're doing an inner join, we're just typically matching on a primary key, foreign key relationship. So the key comparison between those tables is a single column. But with intersect, you see that we're evaluating on multiple columns. So generally speaking, I find inner joins to be a bit more flexible than the intersect, but your mileage may vary. Now then, let's take this theory and put it into practice. Let's fire up Oracle and test some of this stuff out. In this demonstration, we'll work with set operations in Oracle Database 11g. The specific examples that I'm showing you are adapted from this Latvian blog. The article in question is called SQL Set Operators. It's a really nice blog. I encourage you to check it out. Let's bring up our instance of Oracle SQL Developer. I'm logged in as the HR user, and the first thing I'm going to do is create 3 tables. Just to describe what's going on, we formally haven't talked about either the create table or the insert statement, but I think now is a good time for me to at least lightly walk you through this so it doesn't come as much of a surprise when we get to it in the course. Essentially, in our create table statement, we're naming the tables T1, T2, and T3, and then between parentheses we provide our column list. So T1 and T2 both have 2 columns. We have an ID column that's of the integer data type, it can't be null, and we're affixing the primary key constraint. And then the second, the data column, is called LOC for location. It's varchar 10 and also cannot be null. So you'll see that T1 and T2 have the same exact structure. T3 simply has a single column called loc. There's no primary key constraint here. The next several rows we're using the insert data manipulation language statement to put values or data into both T1 and T2. So you see we have several T1s and then we have some table 2s, and we're putting in first the ID value and then a unique location. Because I don't want to execute everything in my script file, I'm just going to come up and select the lines that I'm interested in all the way down to my final insert. I'll then issue commit to make these changes permanent in the database. And then in SQL Developer, we can run the statement by pressing the little arrow. And it looks like everything turned out okay. Oracle was able to create the tables, perform the inserts, and commit the change. Next, let's run some simple select statements again against each table. We're going to select the location data from each one. Here's the location from T1. Looks like there's 10 rows. Here's the location data from table 2. It looks like there's 7 rows. And you should also see that we have some duplication here. We have the same cities appearing in multiple tables. Now you might think, well, isn't that a violation of normalization? And I would say yes. However, especially in data warehouse environments where you have just oodles and oodles of tables and multiple teams working on those tables, sometimes third normal form normalization is more of an ideal than a practical reality. All right, first thing we'll look at is on line 31 here. We're going to run a union on locations in each of those tables. Now you saw the query results separately. That's all well and good. If we want to combine that information, all we have to do is run a union to connect those 2 queries that we already ran. Now the resulting row set gives us only 5 entries. Can any of you, my students, answer me why that's the case? Well, you'll remember that earlier in the training I mentioned that union used alone will omit duplicates. So it looks like we have only 5 unique locations across T1 and T2. I also want to demonstrate by running this query on line 35 that we can shift up the order of our select statements and demonstrate that we get those same results back. There they are. You'll also notice that the row set that comes back is not in alphabetical order. Thus, we have to add an extra line here, order by, and then provide either the column name. You notice that SQL Developer gives us this handy little drop down here, or the ANSI ISO standard for using order by with set operators is actually to use a numeral, if you can believe it. Now in this case, it's not really that big of a deal because we're selecting only one column from these tables. However, as you get fancier in your use of these set operators, you may have a select list that consists of 2, 3, or more columns. When you do order by again, you can use the column name, the column alias, or best practice to use ANSI ISO, use a number to denote the position of the column in the list. Now why is that important? Well, the main reason that the numerals are nice is because it again reduces or eliminates ambiguity. If we order by 1, then that tells Oracle, I don't care whether there's a mismatch in the column names, I'm going to order by the first column indicated in the select. Okay, so let's actually add a statement terminator here, highlight these rows to tell Oracle we want to run them, and the result comes back as you see, ascending sort by that column ID. Now if you want to see everything from those tables, you want to just literally dump every row from T1 into T2. Remember that union all is our helpful keyword in that regard. So we'll select those rows, run this query, and this gives us 17 rows back, which you'll remember is the combination of rows from T1 and T2. And this time I'm going to throw in an order by loc, just to demonstrate that we can do it that way as well by referencing the column name specifically. And sure enough, let's raise this up a little bit more. Lots of duplication location here. We have 5 instances of Eugene, 5 instances of Nashville, 3 of Phoenix, etc. Now, one of the gotchas I taught you when using union and other set operators is to be careful with your column counts. The column count has to be the same. What we have on line 45 is an example of a union statement that involves mismatched columns, or should I say non-matched columns. So on line 45, if we select splat from T1, then we're asking for not only the loc column, but also the ID column. And then if we try to union that with just loc from T2, we're going to have some problems here, aren't we? We can tell that right off the bat. Well, let's prove that by running the query, and we get an ORA 1789 error that says query block has incorrect number of result columns. So that's the deal. In order to fix this, we're going to have to make sure that those columns match. Now, I can alias all day long, but you want to make sure, again, you're aliasing on the top select statement. There we go. Looking good. I think at this point you understand union and union all. It's pretty straightforward stuff and extremely useful. Like I said, the vast majority of your use with set operators is going to be union. That having been said, though, let's take a look at the minus and intersect set operators. First, let's take a look at line 49, where we're running a simple minus operation on our queries. So we're selecting loc from T1 and subtracting from it location from T2. We're left with only Miami and Syracuse. Now, what is this telling us? This is telling us we grab all locations from T1 and then we subtract out any matching locations that appear in T2, you see? So the order is significant. To prove that, let's make a note of our results here. It looks like if we subtract T2 from T1, the resulting set gives us Miami and Syracuse. Now, if we change the order of the table such that T2 is first and we're subtracting T1, let's see what happens there. There's nothing there. So literally, it looks like everything, all cities or locations that appear in T2 must also appear in T1 because they're just eradicated if you're doing minus in that direction. So remember, minus does require you to be careful in ordering your select statements. Next, let's have a look at intersect that looks at matches between multiple tables. Here we're running, again, the same exact query. I intentionally selected this example because of its simplicity. It allows us to focus on the keywords and specifically what they're doing. So if we highlight these rows and run the query, what do you think is happening here? Well, what this is doing is looking for matches between T1 and T2. So it looks like we have instances of Eugene, Nashville, and Phoenix in either table. Now, if we run just 2 separate queries here, and stretch this up a little bit, we have our location 1 that consists of 1, 2, 3, 4, 5 cities: Nashville, Syracuse, Eugene, Phoenix, and Miami. Location from table 2 includes Nashville, Eugene, and Phoenix. So therefore, the matches, again, just to select this row, would be those 3 values. You see where we're going here? Final example of intersect I want to show you is select loc from T1 and intersect that with select loc from T3. Now, you'll remember that there were no inserts earlier in this script that put any data in T3, and I can demonstrate that really quickly by running a select splat from T3. We're not getting anything back, of course, because there's no data in that table. So you might wonder what's going to happen if we try to run an intersect that looks for data matches between those tables. Well, let's select the rows and find out. We get nothing back. It's as simple as that. Final example in this demonstration. Remember I mentioned at the beginning of this nugget, I wanted to show you how you can compare tables by using these set operators. This is kind of some fancy mathematics here. It's called a symmetric difference. It's kind of cute. And what you're doing here is taking select loc from T1 minus select loc from T2. So you're getting the difference between those tables and you're unioning that difference with the same query, just with the table names reversed. Select loc from T2 minus T1. By running this particular query, you're able to compare tables to test for how closely they match each other. Using the set operators review, in this nugget we yet again extended and deepened our use of the SQL select statement. At this point I believe you have a deeper understanding of structured query language, specifically how it works as a set-oriented language, and you also understand both the theory and the practical implementation of the major set operators in Oracle Database 11g, namely union and union all, minus, and intersect. I hope that this has been informative for you, and I'd like to thank you for viewing.